Hi, I'm Carlton Coffrin. This is the first of 3 short presentations which myself and Tim Heidel made at the PES General Meeting in 2016 to kick off a new task force on benchmarks for validating emerging power system algorithms. This is the first presentation, which covers the motivations for this task force. The following presentations will cover the implementation, test case, integration proposals, and then there's another presentation which won't be made into a video that was done by the GridBright group on a new power network repository. So why would we make a new task force? In short, the reason is because power systems are changing. In the first version of the power systems, we had highly regulated, very predictable, hierarchically designed systems which are operated primarily for reliability, not economics. But for many years now, we've been migrating to Power Systems 2.0. This includes things like deregulated markets, much more dynamic systems with distributed renewable energy, actively controlled systems with things like demand response, potentially distributed designs with things like microgrids, and last but not least, they're operated for efficiency while maintaining reliability, for example, through security-constrained optimal power flow. Now, there have been many consequences of this migration to Power Systems 2.0, but one that cuts across many fields is a general move from simulation to optimization. There's many emerging optimization problems like AC optimal power flow, stochastic unit commitment, or power supply restoration, and there are many more. Now, this creates a bit of a problem. Almost every power system optimization problem is NP-hard. Now, the big problem with an NP-hard problem is there's no one-size-fits-all algorithm to solve all of these NP-hard problems. Algorithms need to be tailored to the problem at hand, and there's always very hard inputs which have a worst-case exponential runtime. So you have to consider what about inputs that are more realistic, not the worst ones. So this creates a fundamental challenge for evaluating optimization algorithms. Now, the optimization community has been solving problems like this and developing algorithms for many years, and they take the following approach. They make a collection of interesting test cases. They use that same collection and they put it through multiple different algorithms and they compute performance metrics. And then they compare these metrics to decide which algorithm is better than one another. Now, in a typical mature optimization field, no one algorithm dominates all the other algorithms. Typically what happens is that different algorithms benefit from different classes of input data. As a consequence, the set of input data is a critically important decision. In most of the optimization community, they strive to have fair and representative distributions of inputs, not just one or two, to eliminate bias for one particular algorithm. You can see examples of this with things like the mixed integer programming library, or the satisfiability library, or the constraint satisfaction problem library. All of these are broad collections of test cases which multiple people are comparing their algorithms against. If you try to characterize these libraries, they typically have between hundreds and thousands of cases within them. They usually have a mixture of real-world industry problems, contrived, handcrafted instances that are designed to be very difficult to solve, and synthetic and random cases. They're always community curated, and there's a culture of many researchers contributing new cases to these libraries. And by and large, everyone is testing on this same standard library. At least some of their experiments will use it as a base of comparison. So let's return to our original question. Why make a new task force? There are lots of other valuable and very important test case efforts in PES. If we look at a typical IEEE PES test case working group, we'll see that it focuses on making a few very high-quality data sets. The systems are designed to be generic and often don't have a specific problem in mind. As a consequence, there are tens or even hundreds of variants of test systems. If you look at the IEEE reliability test system from 1996, you can see that this has been used as a basis for hundreds of variants. And another challenge is that these variants are not often shared or compared across multiple publications. This task force is modeled after the optimization community's approach. We're going to focus on collecting large numbers of test cases dedicated to specific and clearly defined problems. We'll make it easy for everyone to contribute to these new cases. And we will make the data very accessible and easy to use and encourage everyone to use the same set of data. The way we'll try to achieve this is by using open access standards and standard formats, at least within one particular problem domain, so it's easy to input lots of different data sets into one algorithm. Now, when you propose a task force, you have to say what you're going to do. So in our task force proposal, we propose to work on power network operations. And the reason why we selected this area is we identified that no other task force was working on these specific type of test cases. These are characterized by steady-state AC network optimization tasks where reactive power has a significant role and include things like switchable bus shunts, on-load tap-changing transformers, phase-shifting transformers, bus splitting, and n-1 reliability. Now this is what we've promised to do, but if other efforts in the test case area like our approach to this problem, we would be very happy to merge with those efforts and all work together to make a bigger and better test case. And if there's more volunteers, we're happy to broaden the scope to other problem domains. It's just a matter of throughput. We can only commit to so much in the application phase. Thank you very much. I hope you enjoy the next video.